Last spring, the processing and engineering departments finally saw the fruit of their labor on a 6-year project. This project was to upgrade the control system in processing and how batches are made at Mary Kay. See, the old system was centralized. It was controlled by one main computer in an area that stood 2 stories high. The technicians had to either manually make adjustments to their batch or run back and forth between their kettle and the computer. Mike Burton, Senior Cosmetic Processing Technician, shares the frustration with the old system.
It had a tendency to overshoot or to not reach the temperature that you wanted to batch at. So you would have to pretty much stay there and monitor it because you sure didn't want to get too hot. And you had to get it hot enough to make the right emulsion or whatever kind of product you're making.
But inconvenience wasn't the only problem. How did system failures affect this centralized system?
It killed the processing area. I mean, they stopped. They couldn't continue on.
As the engineering department started seeking help from outside of Mary Kay, a challenge arose.
There was a problem because what we were asking of the vendors was well beyond what the technology that they had at the time, and most of them told us that we couldn't do it.
So they designed the system themselves. Since then, other vendors have started to support this strategy that began here at Mary Kay Engineering. Now, the new system is set up so system failures are no longer a problem. It's a network which can be compared to a chain, let's say this bracelet. Off of the network are small computers, or nodes. Each node controls one or more kettles. We'll compare these nodes to the charms on this bracelet. If a charm is removed or lost, you still have the bracelet and the other charms. Well, so it is with this network.
Now, if one of the little nodes goes out, you just lose, 1 or 2 kettles, and that's it. And the rest of the plant can continue booking along.
2 of these nodes are located at the Supervisory Control and Data Acquisition, or SCADA. These 2 stations use animation to give quick information.
The animation on the TF3, TF6 system lets you know which valves have been energized, whether or not the sweeps are running, what the level is in a real-time sense. And over on the CIP systems, you can watch the levels change, tell which pumps are running, which ones are not, which valves have been shifted, which ones have not.
The other nodes are located on the network throughout processing. As we mentioned earlier, each node controls 1 or more kettle at a time. They do not use animation, but consist of controls and data.
You can't overheat it. If you set the temperature at a certain temperature, that's where it's going to go and that's where it's going to stay until you turn it off. You're not going to overmix it. You can set your mixing controls and it works great.
Since the controls are simplified and each operator station is consistent, it's easy for new technicians to learn and for present ones to move to different locations. And with heating elements and high-speed instruments involved, how does this affect safety?
An operator can shut off kettles, make changes in the process, and report those changes to the industrial computer.
But what else do technicians like Mike enjoy about the new system?
You can go away and do something else, start your next batch, bring your next batch up. You can do your QC testing for your batch. You can do other projects for your supervisor, help out the new guys, just whatever is needed around here.
The main goal was to have a very flexible system and easy to add on or easy to move.
Garico was the contractor that did help with Mary Kay's requests. What made this such a successful project?
We were very upfront with the contractors that they'd be working in a team effort. It would be they would have to work with our employees just as an employee of their company, and they in turn would have to do the same.
Working closely with the plant personnel helped to get the system put together with minimal amount of time involved in just the designing of it. They knew what they wanted, we were able to put it together for them.
I really like it because we're the ones that use it. We're the ones that would know more about it and how it works.
Where most companies would have shut down entirely for the switchover, Mary Kay was able to continue producing. Plus, by dividing the project into 5 phases, technicians were able to adjust to the new method gradually, so the learning curve was minimized.